but nothing ever stopped me from dusting off my shoes. You might think you'll see me falling to the ground, but I threw up my umbrella when rain stops hitting town. Yeah! On a bad day, on a good day, I don't need no sunshine, 'cause I'm dancing with the rain. You will see me running, thinking I might be insane. I don't need no sunshine, you keep me going strong. I just need my happy face to keep me moving on. Looking out the window, reflecting who I am. No one ever stopped me, not even Uncle Sam. Life might be a struggle, life might be a fight, but I am here to show the world that I can make it right.
Hi, guys. Good evening. Welcome to Environmental Coffee House. And I am Sandy Schoelles, as usual. I haven't changed. And this is Jennifer Hynes, my partner, my buddy, my best friend, my everything. And my chit-chatter all week and just everything. And how is everybody? It's good to see you, Jen. We have a
Yeah,
pretty good show tonight. Again, we are going to
We
go over
do.
the AMOC again. You never can get
Oh,
too much
yeah.
AMOC, right?
no, especially right now.
No.
It's a hot topic. Haha.
Yeah, well, it's new research, and we have some graphics, and Jennifer, like usual, she's going to go through what we have as far as articles to start, and then we're going to start. We're probably going to the first one is really the most important, and then we have definite cool graphics
Yeah.
to talk about. And so, Jen, you want to get started?
Yeah.
and tell everybody what's going on.
Absolutely.
What's going
I
on?
will.
All
All right,
right.
guys. So we're going to take a deep dive into the AMOC and all things AMOC, all new research,
Yeah.
and all new studies. So the first one, it's all from phys.org, by the way, guys,
Yeah.
phys.org. Very good periodical. So the first one, just out, record high Arctic freshwater will flow to Labrador Sea, affecting local and global oceans. So we're going to talk a little about the Arctic freshwater, which is very fresh, right?
Mhm.
It's not very salty at all, flowing through the Canadian archipelago and what that means.
Yes, we are.
Then the next one is also from phys.org, just out. Gulf Stream system at its weakest in over a millennium.
Oh my.
So brought to you by human-caused climate change. And I just lost one of my articles.
Oh, you'll find it.
Why a net future depends on the ocean's ability to absorb carbon. I'm not sure which one that one is in.
We'll figure
Is
it out
that the
when
next
we're ready.
one?
We've got it.
Let me see
We've
if I
got
can
it.
get that one back.
Yep.
I
And
can't
if you
link it
don't,
back
I'll
in.
send it to you. Everybody's cool.
No,
with
I
all
got
of
it.
our-
It's just it kind of got
All right.
disjointed.
All right.
Then the next one, unfortunate timing and rate of change
Oh, yes.
may be enough to tip a climate system. So we're going to be talking about the rate of change as it applies to the AMOC and
Okay.
what that's all.
All right. And listen, guys, I don't want you to mind, but I'm drinking a little cheap wine tonight, not coffee, because if I drink coffee, I'll never go to sleep. And I've been, oh my God, I've been in a lot of pain lately. But the show must go on.
The show must go on.
The show, and that will get the first environmental podcast flush of the day. All right, show must go on. Cheers. Yep, cheers, guys. So I just wanted to do a little housekeeping really quickly because I wanted to show you something that Jim and I don't know if Jim and Tanya are with us yet, but they sent me something really cool. Tanya is amazing, Jim's wife, that does the every Friday climate emergency broadcast in Gettysburg, Pennsylvania, and people are so beautiful. She sent me this. Now you're going to say, what is that? Like Jennifer said. Well, this is a compost knife. Measuring, you can measure with it. You can cut your garden stuff. You wear it on your hip. And I just wanted to give Tanya a big thank you because she said she wears this all summer long off her belt. And if I can fit into one of my belts, I'll be wearing this too. So thank you, Tanya, because things like this are invaluable when you are a gardener and you compost and you do all that stuff. So there you go. And I wanted to say thank you because people are beautiful. There you go. So what do you say, Jen? How do we want to start this? Jen has a little cough, but she'll be okay. It's nothing to worry about.
Yeah.
It's just winter.
Thank God for the mute button. Right. I'm just recovering from a little sore throat, but nothing, no big deal.
Okay.
Okay. Let's go ahead and get started and dive into it.
Okay. I will get started by putting our names down on the bottom. And which article first? We're going to go through the big one. The freshwater
the
one.
record high Arctic freshwater will flow to Labrador Sea. So this is pretty interesting because this has to do with how fresher water, because the Arctic's quite fresh and the Atlantic's quite salty. And as we all know, fresh water is lighter than salty water. And so this is going to affect the turn of things. Mm-hmm. But a lot of this fresh hot water from the Arctic, relatively hot speaking anyway, is flowing right through the Canadian archipelago, and it's flowing down the west side of Greenland, and it's not going around and through the Fram Strait like you would think it is. So,
nope. And don't forget, we have a little vignette on a bunch of scientists talking about the AMOC.
Yeah.
So you let me know when you want to put that one on. I'll put it on, Jen.
Okay, that sounds good.
Okay.
So, to kind of benefit everybody, I'm going to try not to read everything verbatim. I'll try and paraphrase it. We'll see how we do.
This is an important one. So even if we read this one and paraphrase the other ones, this one's the most important. And it was all over Twitter. So.
Oh, okay.
Go for it, baby. So go for it.
Thank you, sweetie. So the main thing is the fresh water is accumulating in the Arctic Ocean. And the Beaufort Sea, which is the largest Arctic freshwater reservoir, has increased its freshwater content by 40% over the past 2 decades. That's huge, really.
Yeah. It's not like we didn't know, but now we have definitive mechanisms and methods, and we'll show you the methods they use too.
Yeah. And the main thing is how and where this water will flow into the Atlantic Ocean is important for local and global conditions. So there was a study, kind of a joint study in many different organizations, including NOAA. And this study shows that fresh water travels through the Canadian archipelago to reach the Labrador Sea, rather than through the wider marine passageways that connect to Northern Europe. So that's like the Fram Strait. So this water is actually leaking through the entire Canadian archipelago and flowing down the west side of Greenland. The Canadian archipelago is a major conduit between the Arctic and the North Atlantic. And in the future, if the winds get weaker and the fresh water gets released, there is a potential for this high amount of water to have a big influence in the Labrador Sea region. So the Labrador Sea, just to kind of orient you guys, it goes along the west side of Greenland, between Greenland and Canada, that kind of skinny channel, which actually is hugely deep. I didn't know it, but it's over 3,000 meters deep. Can you believe that?
It's a deep one.
Absolutely huge. So this has implications for the Labrador Sea marine environment, since the Arctic water tends to be fresher, but also rich in nutrients. Very important for phytoplankton.
Yeah.
So this pathway that it's taking also affects larger oceanic currents, namely the AMOC conveyor belt in the Atlantic Ocean, which is colder, heavier water sinks in the North Atlantic and comes back along the surface as the Gulf Stream. So fresher, lighter water, which this is, entering the Labrador Sea could slow that overturning circulation. So this is what people have worried about for a long time. And in fact, it's happening. And this is very much the day, what was that Hollywood movie, The Day After Tomorrow?
Oh, was it?
Yeah.
Should we do the little AMOC video before we continue this for those that need to catch up on it? Why don't we do that? It's only 2 minutes, and I think it'll help those of you that may need a little refresher course on AMOC. So we'll do this, and we'll be right back, because this is it's actually pretty good.
AMOC stands for Atlantic Meridional Overturning Circulation.
So the Atlantic Meridional Overturning Circulation is a long way of explaining what the sort of overall large-scale circulation pattern in the Atlantic is.
So this thing that we call the AMOC is basically a system of ocean currents that takes warm water in the upper part of the ocean northwards from the equator up to the high latitudes, and then that water cools and gets fresher along that pathway, and then that makes the water sink and it returns southward again at depth.
So most people who understand about the ocean might think about the surface currents like the Gulf Stream, or some people may have heard about the Kuroshio current, and all of these are visible from space when we look at these ocean gyres, and we understand them in terms of how the wind is moving the water. But the overturning circulation is largely hidden from us, except for ocean instruments, because the overturning circulation involves waters that are initially at the surface, but then they sink, and these waters flow throughout the global ocean, up well in distant parts, and then they return.
The ocean is about 4,000 meters, about a few miles, 3 miles deep on average. And that deep water doesn't see the surface all the time. In fact, it takes hundreds of years for the whole ocean to turn over. And so the AMOC is our oceanographic label for the process by which that deep ocean circulation develops, and water at the bottom gets a chance to come to the surface, where it's renewed, where it sees the atmosphere, and then goes back into the deep ocean. So it's the turnover of the whole oceans from surface to bottom.
The Atlantic Ocean transports more heat northwards than the Pacific does, even though it's a really skinny basin, and that's because it's got this overturning circulation, which just doesn't have an analogue in the Pacific.
This movement of heat from the low latitudes to the high latitudes basically makes large parts of the planet habitable in a way that they wouldn't be without the ocean.
And this is the heat engine of the planet.
And so any disruption to that pattern, any change in that overturning circulation, means we're going to have a change then in how that heat is redistributed, which means a change in climate.
And there you go, a change in climate. And we don't know if it's happening, faster than previously expected, but the science has told us it's happening, and the research was done with dye, and it's pretty interesting. But Jen, I'll let you get refreshed back into the article.
Yeah. And what's also important to know about, there's something called the Beaufort Gyre, and it goes clockwise, and it's just kind of north of Alaska, over on that side of the Arctic, right? And it spins around, and that's kind of a circulator within the Arctic. So right now, the fresh water is still trapped in the Arctic, but once it gets out, this can have a very large impact. So this fresher water reaches the Arctic Ocean through rain, snow, rivers, inflows from the relatively fresher Pacific Ocean, right, over by Alaska and Siberia, where they come together, as well as the recent melting of the Arctic Ocean sea ice, because even though the sea ice is forming in salt water, the ice that forms is pretty fresh itself. All right. So this fresher, lighter water floats on top clockwise, winds in the Beaufort Sea, and it pushes this light water together to create a dome. So it actually creates a dome of fresh water. You know, we always think of the sea as flat, right? But it actually has domes within it. Yeah. When the winds relax, the dome will flatten and the fresh water gets released. So it kind of like builds up, makes a dome, and then the winds relax, and then it just gets released into the North Atlantic.
Pretty wild.
A lot of people have spent a lot of time studying why the Beaufort Sea freshwater has gotten so high in the past few decades, but they rarely care where the freshwater goes, and we think that's much more of an important problem.
It is a very important problem, but not, you know, who knows, who cares? Like we do, and that's why we're here, to try to get other people to understand and care, because it will have effects for the rest of the oceans, for the rest of the planet. It's here.
Yeah. So they have developed a technique to track ocean salinity, and they have built models and simulate the ocean circulation, and they followed the Beaufort Sea freshwater spread in an event that occurred from 83 to 95. And this experiment that they conducted shows that most of the fresh water reached the Labrador Sea through the Canadian archipelago. And this is a complex set of narrow passages between Canada and Greenland. They have a real good picture of it in here, Sandy, if you feel like displaying that.
I'm wondering if I have it in a, all right.
And any picture that shows the Arctic and Canada, there's like a huge passage that goes through the north of the Canadian archipelago, and it hits Greenland and dumps into the Labrador Sea. There's a couple of different passages, but one main one.
We do have I do have one that's very interesting on how the scientists are doing this with the tracer diagnosis, how they track the volume transport, and they initialized it in the region from surface to the reference depth, and then zero outside, and they reset it. They advected. That word is a science word for me, but advected. So see how they can see with the dye and the salt. It's pretty fascinating how
it really is. That's the one I was talking about.
Yeah. Okay, good. I got the right one. Yeah, it's pretty wild, I think.
Yeah, it is. It's really wild. So the volume of fresh water in the Beaufort Sea is increasing. It's about twice the size as the case that they studied, and it's, for the record, 23,300 cubic kilometers. Wow. Hard to envision how much that is, but more than 5,500 cubic miles. Yeah, it's a lot of fresh water.
Big.
And the volume of fresh water that's released into the North Atlantic could have significant effects. So this study has focused on past events. Current research is looking at where today's freshwater buildup might end up and what changes it could trigger. A freshwater release of this size into the subpolar North Atlantic could impact critical circulation pattern called the Atlantic Meridional Overturning Circulation, affectionately known as the AMOC.
Yes. AMOC.
which has a significant influence on the northern hemisphere climate.
And
So net, that's what that article is about.
Yeah, and it did get a lot of people's attention this week. It sure did. And another one I have is the summary of the research that of the Beaufort Gyre liquid freshwater content, and the objective was to explore the fate of the Beaufort Gyre freshwater after it's released, and to quantify its downstream impact on the subpolar North Atlantic salinity. So it's pretty interesting, guys, if you want to go back and look at this whole thing afterwards. They had the findings that the freshwater exited the Arctic mostly through the Canadian Arctic, just archipelago, just like Jennifer read and talked about, and the Labrador Sea being the most affected region in the North Atlantic, and the implications, potential impact on the AMOC, the impact of a future rapid release on Labrador Sea salinity, which could be significant, easily exceeding similar fluxes from the Greenland meltwater. So these things are serious in that they are going to affect the whole planet somehow. They're going to affect the whole planet. Oh yeah.
Well, you know, I mean, our entire climate depends on this continuing AMOC current
conveyor belt. The conveyor belt. Yeah.
And actually, Northern Europe is warmed by the AMOC right now. But if it stops, clearly that warming is going to stop. And conversely, Northern Europe may experience cooling in that case.
And that's where people say, oh, well, we're going to have another ice age, which really we're not, but it's going to seem like it to certain people in specific locations that are affected by that, the temperature change from that.
Yeah.
Yeah. So there was another one that showed, I want to know, Jennifer, what you, wait a minute, let me get us both on this. This one was the salinity.
Very interesting. Okay,
Yeah,
so that's a very interesting thing to talk about. I want to see, do you see like, so the bluer it is, the fresher it is, right?
Yes.
And do you see how there are like bulges of blue over by the Beaufort Gyre? And then straight up under the word salinity, there's a big bulge of blue. That's the output of the Lena River. And then there are two rivers over in the Kara Sea, and you can see another bulge of blue there. And I can't remember what those two rivers are, but there are two main rivers that come out right over by the Yamal Peninsula and the Kara Sea. And that is all adding to the freshness of the water. So over in Alaska, where it says Beaufort Gyre, that's the Mackenzie River coming out there. So these rivers contribute a lot of fresh water that all gets dumped into the Arctic. And it's finding its way into the Atlantic. So you can see how salty the Atlantic is. The Atlantic is the saltiest ocean, I believe. The Pacific is a lot fresher than the Atlantic, oddly enough.
And it affects all of the sea life. Everything will have to acclimate. Well, they are already acclimating. They are already having to, the moving of different kinds of organisms to different areas. We're seeing this already. I don't have anything on that to look at, but we are seeing these things already. And like you said, it's affect phytoplankton, which is like the core, you know, the base.
Yeah, that's right.
Let's see if I have anything else on this that was interesting. The freshwater. These were kind of we had the information on these from the other article, and if I can pull it up really quickly, I can pull up, it's just the last article. It is the actual research. If you can see it, I'm gonna take this off, but I'm gonna show you the actual from Nature Communications. Can you see this, guys? And it does describe, they go through every single, and this will be in the show notes, every single graph that they have in here, that like the one we just looked at with the salinity, and then the all these different ones, the liquid freshwater content and the narrations about exactly specifically what they are. Jennifer, is there anything you want to go over in any of these?
No, not on that one.
Okay. We had this was the one, I think this was an interesting one, this fate, the full size image. Let's see if we can see it. It was the distribution of vertically the dye. Can you see that? The dye, how integrated dye tracer concentration by the end of each 13-year simulation. So 1983 to 1995 with rapid release of fresh water. So it's pretty cool.
Okay.
You can, your visual. I mean, we're not scientists, but the visuals are helpful. I think they're helpful to at least get an idea of what these scientists are looking at. I mean, we're not going to sit here and tell you that, we're going to go through all of this specifically, but you guys get it, you get it. And so that was the other one, the downstream was that. Oh, this has a lot of graphs in it. And if I can find the narration on this one, yeah, let me read this narration on this one. This is changes of the upper, and I'm not going to read all the different numbers, but the salinity induced by the Beaufort gyre sourced water during the last 3 years of their research, which they call, the A and the fast acceleration, fast release minus. So it's their scientific method, but each one here is pretty fascinating in the different time zones. And again, I'm not going to pretend that we are completely versed in it. It's just really interesting. And if we had time to go back to school and get a degree in marine biology or oceanography, we should have had Jim come in for this. But I didn't know what happened. I didn't get in touch with Jim today, but it would be interesting to do that if you had a second life to live over. I would go back to school for something in this. But so where do you
I
want to
kind of
go
feel
next?
like we are in school. We're in school real
sure,
time,
you're right.
doing this show.
You're right. We learn a whole lot.
School of
Researching.
climate science,
She's right. You know what? We're trying to teach you what we learn, the layperson's higher education here.
Yeah, just because we don't get a degree in it doesn't mean that we can't learn it, right?
That's true.
We're learning it every day.
So
this next article is the Gulf Stream system is at its weakest in over a millennium. And it's pretty interesting how much the Atlantic Meridional Overturning Circulation, the AMOC, has slowed down. And it's related with the Gulf Stream. The Gulf Stream system is part of it. That's the part that goes basically from Florida up the east coast of the United States and swings over to Northern Europe and England.
Brings cooling.
Before it kind of loops. It brings warming. It brings
warming. Sorry, I turned it around in my head. I'm thinking of Patrick's.
You're thinking of those ocean tunnels. Yeah. He's gotten in your head.
Yeah. I'm surprised he's not here with us tonight. I would think he would have seen this AMOC on Facebook and he would have been here.
That's okay.
Oh gosh. All right.
So we have another study here in this article, and it's talking about the Gulf Stream, which works like a giant conveyor belt, carrying the warm surface water from the equator up north.
Not the trailer, guys. Not a Gulf Stream trailer.
Right. Sending cold, low salinity, deep water back down south. So it moves nearly 20 million cubic meters of water per second. This is about 100 times the flow of the Amazon. And Stefan Rahmstorf is very prominent in this article. Actually, it was his organization that wrote this article. He has the Potsdam Institute for Climate Impact Research.
Yep.
Yeah.
Watched a lot of his videos.
Yeah, I watched one today.
Oh, you did?
Yeah.
Cool.
Yeah. He's great. Hard science, really good. No nonsense. So what they have shown is that the ocean current is slowing down about 15% since the mid 20th century. This is like lightning speed. It sounds like, 15% in 50 years or 70 years, that's not too much. I mean, it's lightning speed, and it is linked to human-caused global warming. And so they used a proxy data study in order to do this. So net, they have combined a range of previous studies, and they have found a consistent picture of AMOC evolution over the past 1,600 years.
Yeah, this was cool.
Ramsdorff said. So basically, they have reconstructed the AMOC over a 1,600-year time frame. And that's how they can make these statements like it's slower than it has been in a millennium, right? So there was a little phenomenon called the Little Ice Age that happened around 1850 for a few years. It may have been linked to volcanic activity in Indonesia, possibly. I'm not exactly sure what caused the Little Ice Age. But after that, the ocean currents began to decline, and we had a more drastic decline since the mid 20th century, so like the past 70 years. Yeah. And let's see, from temperature to flow speed changes, the art of reconstructing past climate changes. The AMOC measurements started only in 2004, which kind of surprised me. I thought they would have been doing direct measurements more since then, but I guess I don't know how they do it actually, because the AMOC's invisible. You can't really see it. It's under the water, and then it goes deep under the water, so it's hard to track it. And they're talking a lot about proxy data. I don't think that part's that interesting. But basically, they have gathered this proxy data from natural environmental archives, such as tree rings, ice cores, ocean sediments, and corals, as well as from historical data from ship logs. So they put this all together, and they reconstructed the flow and the track of the AMOC, which I think is just amazing.
Me too.
Yes, amazing.
When I read this, I was really in awe that this is
right. So I guess that's what they call proxy data. So it is kind of interesting. It's all the different sources, that they gather together. So they used a combination of 3 types of data to obtain information about the currents. They used temperature patterns in the Atlantic Ocean. They used subsurface water mass properties, and they used deep sea sediment grain sizes dating back from 100 to 1,600 years ago. Yeah. Wow. So they acknowledge that it's possibly imperfect, this proxy data, in representing the AMOC evolution, but it's the best thing that we have right now.
I was just going to say, it's the best we got.
Yeah, exactly.
It'll only get better.
At least they've assembled it. It's kind of amazing that they've been able to put all that together.
I agree.
Let's see. This is all about some data sets, kind of dry.
Okay.
Assuming the processes measured in proxy records reflect changes in the AMOC, they provide a consistent picture, despite the different locations and timescales represented within the data. Overall, the AMOC has weakened unprecedentedly in over 1,000 years.
And probably
so why
worse
is it
in the last 200?
Oh, definitely. Definitely. So why is it slowing down? This AMOC slowdown has long been predicted by climate models as a response to global warming caused by greenhouse gases.
There you go.
A number of studies. Yeah, exactly. have observed this weakening. The Atlantic overturning is driven by what scientists call deep convection. And this is triggered by the differences in density of the ocean water. Warm and salty water moves from the south to the north, where it cools down and thus gets denser. When it is heavy enough, the water sinks to the deeper ocean and flows back to the south. This is how it's supposed to work.
Right.
But global warming
The big
disturbs this. Global warming disturbs this
Sorry.
mechanism. And also, you'll know that we've been getting more rainfall. Why have we been getting more rainfall? For every degree that that the air goes up in Earth, right? The average air temperature, there's 7% more humidity, and that's 7% more water that's going to come down. So there has been increased rainfall, and it's happening. So increased rainfall and enhanced melting of the Greenland ice sheet add fresh water to the surface ocean, both those things. Of course, Greenland is really melting, of course, as we know.
Yeah, and going south. Torstein is here with
So-
us, can tell us.
Yay.
Yay.
Yes, he can.
Yes.
And this fresh water reduces the salinity and the density of the water, and it inhibits the sinking, and thus this weakens the flow of the AMOC. So this weakening has also been linked to unique substantial cooling of the northern Atlantic over the past 100 years. This is the so-called cold blob, and it was predicted, but now it's there. And this is basically the runoff from the Greenland ice sheet, which is
The blob.
running off into the ocean and creating a giant cold blob, which results in the weakening of the AMOC and which transports less heat into
Damn,
this region.
Jennifer, I should have had a blob.
A big
What would a
blob.
blob sound effect sound like?
I don't know. I don't think the
Oh,
blobs
well.
make sounds.
No, I don't think they do. I don't think so. No. Oh, gosh.
Yeah. So more science. The northward surface flow of the AMOC leads to a deflection of water masses to the right. So that would be, if you're looking at a map, the right would be to the east, away from the U.S. East Coast. This is due to the Earth's rotation, which diverts moving objects such as currents to the right in the northern hemisphere, and just FYI, to the left in the southern hemisphere.
Sounds like a
So
dance.
as yeah, exactly,
Move
right.
to the left and move
Grab
to
your
the right.
partner.
Grab your
Do-si-do.
partner, AMOC dough.
AMOC dough.
See what just a
As-
tiny little bit of wine can bring a little bit of silliness, but my back doesn't hurt. There you go.
Oh, good. More wine.
No, that's all I can have.
Okay.
Good.
As this current slows, the effect weakens and more water can pile up at the U.S. East Coast, leading to an enhanced sea level rise. Now, this is fascinating. So this is like a 50-car pileup on a freeway, right? So if the AMOC is slowing down, right, that means that everything that's kind of in the train, in the column of water of the AMOC, it can't keep going because it's slowing down. So it kind of bunches up, and it bunches up on the U.S. East Coast, which is already experiencing incredible sea level rise, right?
Yeah.
And this leads to an enhanced level of sea level rise. So as well as sea level rise from the melting ice sheets, sea level rise from the increased temperatures, right? Hot water is bigger than cold water. And sea level rise due to this bunching up, the slowing of the current, and everything kind of is piling up. And I read that it has risen, or it will rise, I'm not sure, 30 centimeters due to this bunch up, right? Due to the weakening AMOC. Yeah. Along the east coast of the United States. So the east coast of the United States having a big problem.
Is it more
Now
in
in
the
Europe,
southeast, Jen, or is it all along, even just
All
like
along.
Long Island and all the way going all the way up to Maine.
All the way up. Yeah, all the way up. But I think that the mid-Atlantic area might feel it more intensely because that land is subsiding anyway, you know? So, I mean, there's land subsidence, there's temperature increase of water, there's sea level rise from ice, and there's this AMOC. You know, AMOC slowing down is also causing sea level rise along the east coast of the United States. So run for your lives.
Yeah, right. Oh, my God.
Yeah.
Well, I think, you know what? You want to move on? We are 40 minutes, and I'm trying to... I want to get to this. I'm trying to make it through. I am having problems sitting, but I want to go through this one, which was why a net zero future depends on the ocean's ability to absorb carbon now. So this one also in Phys Org, which is Phys Org is a plethora of information. And another thing that they do is if you go down to the bottom of their articles, they will, wait a minute, you can see, they will have a whole listing of other articles related to the article you're reading. So basically you really can get a ton of information from this one publication, and everybody uses this publication because it has all the links to the scientists, all the links to the research. It's like one shop stopping, and it isn't just it's not just like mainstream media, but
no, and it has so, I mean, this can be a whole course. If you have the passion for these subjects, you can just basically master these subjects just by going through all the links at the end of the articles.
Yeah, exactly. And that's what makes it so interesting. So this is a Canadian article, and they're talking about most of us growing up along Canada's east coast never worried about hurricane season, except for those working at sea. We viewed hurricanes as extreme events in remote tropical regions, seen only through blurred footage of flailing palm trees on the 6 o'clock news. But today, a warming ocean spins the hurricanes faster and makes them wetter and drives them towards the Atlantic Canada and even further inland. So hurricanes, winter storms, rising sea levels will continue to worsen unless we slow climate change. And we have to, no matter, by all means necessary, I guess that is what's going to happen. So we are going to try, the powers that be are going to try their hardest. The lifeblood of coastal economies and societies has always been the connection between land and sea. And that's become more evident with climate change. But this isn't just a coastal story anymore. The oceans moderate the world's climate, right? They moderate the world's climate through the absorption of heat and carbon. And just how much carbon the ocean will continue to absorb for us remains an open question. Whatever we do, it must be grounded in our growing wisdom of the deep connections between life and land and in the sea. So as Canada commits to a net zero future and plans its post-COVID economic recovery, innovations and investments could backfire if they reduce the ocean's ability to absorb our excesses, right? So the links between the land and sea. The ocean has always directly affected the climate on land. The well-being of communities across the globe is directly linked to the ocean's capacity to continue its regulating role of heat and carbon cycles. So drought in the prairies is tied to water temperatures in the Atlantic and Pacific Oceans. When temperatures are more extreme, they signal the possible arrival of a mega drought. In Australia, the occurrence of below average rainfall lasting several years can be predicted by high Indian Ocean temperatures. I found this to be quite interesting when I was reading this the first go round. Because everything's so connected, This dries the soils and lowers river flows, resulting in major community impacts such as water restrictions, declines in agricultural production, and increased frequency of bushfires, which we saw all of that in Australia. Now, the success of Canada's climate policies will therefore hinge on understanding how ocean processes are changing and society responds. We know how society is going to respond. Society is going to do everything possible, and nor am I here to comment, on a negative or affirmative. We know that that's going to happen. Is there the political will? It's starting a little bit, but we shall see. Canada, they have committed to net zero carbon in 2050 and to economic recovery once the COVID-19 pandemic has passed. The federal government's throne speech in September, the throne speech, don't you like the way that's highlighted? I'm just thinking about what's his name there sitting on the throne. And when I think of a throne, I think of that. All right, I have to stop being silly. So he's calling it the blue economy, mentioned that the throne speech includes fisheries, aquaculture, and offshore wind energy. So these two commitments are fundamentally linked. Economic recovery and carbon neutrality both depend on the ocean's ability to regulate climate through heat and carbon absorption. But the development of national policies on climate change, both in Canada and internationally, is generally ignored. And this was another one that, I realized that, but I didn't realize it was quite like this. Ignored the ocean in the calculations. Scientists lobbied intensely before the Paris Agreement just to make sure the ocean was mentioned. And changes, really, seriously. Changes to the carbon sink. We dare not further neglect the most important global storage depot on Earth. The ocean stores hundreds of times the heat and 50 times more carbon than the atmosphere, and takes up more carbon than all of the rainforests combined. So basically, Jennifer, the oceans get screwed. We are screwed. I mean, generally, basically, that's it. So, where was I? Ocean carbon and heat absorption also provide a critical natural timescale against which we can measure our effectiveness in battling climate change. Fluctuations in the ocean carbon sink, the amount of carbon in the ocean can remove from the atmosphere will change the urgency with which we need to act. For example, a waning carbon sink. Yeah, waning carbon sink. It shrinks our window to curb land-based carbon emissions, but a growing sink might give us more time to enact difficult but necessary carbon policies that will have disruptive economic consequences. There's no time for delay. No, of course not. And rewards come quickly. Strong scientific evidence demonstrates that ocean processes controlling this absorption can either weaken or strengthen measurably in just a few decades. So heat is absorbed physically from the atmosphere and mixed through the ocean on the scales of millennia. But carbon is absorbed through a complex network of chemical and biological processes, including coastal ecosystems such as kelp and mangroves and seagrasses that will sustain the local economies. And plankton, once again, plankton's the star of the show. The tiny plants and animals that feed everything from mussels to whales, they store carbon. So their behavior and biology became a critical factor in the climate discussion. So I don't know if I want to go through the rest of this other than it's a very important article. And these researchers, including those at the Ocean Frontier Institute, where the authors are based, are poised to address the fundamental questions about the ongoing role of absorbing the carbon. And the role of the ocean has been neglected for too long and must be drawn to the center of the carbon discussion as we plot our trajectory to net zero carbon in 2050. Canada's carbon policies can lead the way internationally if they are grounded in strongly integrated natural and social sciences. It is time for the research community to step up their support. And so you see all the related stories. You can see the related stories. Well, they even there's comments in this one, but there's even more in some of the articles, like some heavy research. So I thought that was a really good one to bring into our ocean night.
You know what was really fascinating about that? That they had to lobby to get the ocean mentioned in the Paris climate. What?
That's crazy.
It's so unconscious. It's,
well,
so
it was, I guess that, scientists have known, but it's, again, political will. And if the political will is not there, and if there are politicians involved, it's going to always take longer. Always.
Yeah.
Because they're always suspect. They don't believe. There's always denialism. There's always something. So you're right. It's kind of a shock. And when I first read this, I was, wow, I didn't even realize that it was like that. So, and here we go. We have one more, which I think we could tag team. And this one is the unfortunate. Now, this one is sort of a kind of a be careful one, kind of a giving you pause. Unfortunate timing and the rate of climate change may be enough to tip a climate system. So,
and this, the key about this article, the whole key is the momentum. The rate of change is so huge. It's so fast that's the whole key to this article, right?
It is. You want to start it?
Sure.
Go for it.
All right. Imagine abrupt shifts of the tropical monsoons, reductions in northern hemisphere rainfall, and strengthening of the North Atlantic storm tracks within decades. These are some of the impacts that climate scientists expect if the Atlantic Meridional Overturning Circulation, AMOC, which redistributes the heat from the equatorial regions to the northern hemisphere, suddenly tips into a dormant state as a result of global warming. The consequences would drastically alter conditions for agriculture, biodiversity, and the economy in large parts of the world. So this was a model study, and it suggests that the AMOC and potentially other climate subsystems are approaching tipping points that might tip long before anticipated because of the rate-induced tipping.
Now remember, they use the word might because this is a cautionary tale.
Right. Well, we'll see. There is a growing concern among climate scientists that several climatic subsystems might tip irreversibly and abruptly to a new state if atmospheric CO2 levels are pushed beyond still yet unknown thresholds. These subsystems include the ice sheets of Antarctica and Greenland, the Amazon rainforest, the Asian-Australian monsoon, the sea ice of the Arctic Ocean, and the AMOC. So all those systems work together, and they all affect each other.
All of them.
It is still uncertain whether rate-induced tipping effects might also occur. These effects manifest themselves as tipping of the system to a new state, even before a theoretical threshold in the external conditions, such as the atmospheric CO2 level, is reached. This is the scary part, right? In rate-induced tipping, the rate of change, not the amount of change, is the important factor. This is because tipping occurs more readily when the system's conditions change rather quickly. And as you all know, we're going into the 6th great extinction much faster than the Earth went into the Permian mass extinction 250 million years ago. That was the biggest one so far. So this rate-induced tipping in the climate system is investigated in a complex ocean model. Do you want to take it up? Inherently unpredictable?
Yeah. So basically, they're saying the model's tipping threshold at let's see, what do I have that up? At very slow increases of North Atlantic freshwater input was identified. Then a series of experiments were carried out where the freshwater input was increased at varying rates, but only to levels below the tipping threshold. The results clearly showed the characteristics of rate-induced tipping. Specifically, when the model ocean was subjected to increases in freshwater input in the North Atlantic, which simulated accelerating melt from the Greenland ice sheet over timescales of 10 to 150 years, the AMOC had a strong tendency to tip to a dormant state before its threshold was reached. Now, it also appeared that due to chaotic dynamics of the ocean model, the rate-induced tipping was highly sensitive to minute changes in the initial conditions, and the rate of change meltwater increase. That makes the tipping threshold fuzzy. Therefore, the qualitative fate of the ocean circulation, i.e. whether it collapse or remain like the modern state, remains inherently unpredictable. Now, worrying, if real. Now, this is where this is why it's a kind of a be careful kind of article, because the occurrence of rate-induced tipping in a global ocean model gives important evidence that one or more climate subsystems may tip from being pushed too quickly as a result of global warming. Whether this is indeed a reality remains to be shown across more models in the climate model hierarchy. So how the findings, they point to the fundamental limitations in climate predictability, and they corroborate the absolute undeniable need to limit CO2 emissions in order to stay away from dangerous and unpredictable tipping. It's worrying news, because if this is true, it reduces our safe operating space. So that article basically, again, it was one of those articles where it's it could happen, it might happen, and whatever, but it's still really interesting, and they're taking the safe route, to put the brakes on, to say that we really have to do this. We really have to get down. We have to get the CO2 under control. Whether or not you guys think that it can happen or not, it's going to happen. They're going to try to make it happen. The scientists, the universities, if there's political will, and I'm not going to say no. I hate the fossil fuel industry. Yuck.
Yeah.
So,
I mean, this article was interesting because very few articles that I've seen talk about momentum, the rate of change. And it's always been my thought that the rate of change that we're doing, to our atmosphere is very, very high. And this is going to have an effect, because you can't just stop a rate of change suddenly. It's got its own sort of momentum. Once you kick this thing going, it's got a momentum of its own, And, thus far, we haven't really been able to control the climate, and it's not like.
But do we want
it's
to
not like
control it with any kind of geoengineering? No.
Yeah. And we haven't been able to reduce greenhouse gases. Even in COVID, as we saw, greenhouse gases were reduced, but the temperatures actually got hotter in the cities because of the particulation falling out due to global dimming, right? Yeah. So it's a tough tale. It's kind of grim, right? But those of us who like to look at this and study it for some odd reason, you know who you are.
Because it's
We
fascinating.
can see what's happening. It is fascinating. I mean, it's the most fascinating thing on earth, I think. I mean, that's why I study it all the time. I love
Absolutely.
it. It's, I mean,
Yeah.
I hate it. I hate it,
know.
but I love it.
We don't
know?
like what's happening, but we are witnessing. We are witnessing something that no one else ever got to witness, and we are sharing it with you. And thank you guys. If anybody does donate to our fundraiser, by the way, I just wanted to tell you, thank you. And we are at the hour mark, Jennifer. Does anybody have any comments? I had some comments. There's a lot of comments here. We have a lot of people with us. Paul and Gazer and Kim, thank you. And Kent and Osama and Billy Joe, Rich, Going South, Kay, Anthony, Paul. It's been a great group. Thank you so much, Basil. Thank you guys so much, Anthony Davis. He said this: the Earth is in some kind of transmission due to the fact that we have removed like 90% of all the trees and turned the surface of the planet into a parking lot. Right? That reminds you of Joni Mitchell. Yeah,
that's true.
So,
right.
But we do. Scott Andrews, thank you. He said that the tipping point's done tipped over decades ago, and it depends on who you talk to. It really does, and with some of the scientists, because some of them have, they have to follow what their university tells them to. Oh, wait a minute. Well, I know, but as 20 years in there, if you have a sponsored program and you're a principal investigator and you veer too far away, you lose your funding. I mean, that's just a fact. You have deliverables, and your deliverables are what what was in the what was in your grant program. And so, you got to, as a principal investigator, you have to be very careful. And what did Kent say? Could be a long night. Well, no, it's not, because we're almost over. And somebody asked about what our fundraiser is. It's called Buy Me a Coffee, and it's to help with basically Wi-Fi. I'm going to tell you, subscriptions and Wi-Fi. It costs a fortune for me to do this, for these subscriptions to do this stuff. And that's all. I've never.
The Buy Me a Coffee link is in the show notes.
Yeah.
And it is cute. It's only like in increments of $5. So you could just contribute $5. That's why it's called Buy Me a Coffee. And you can hook it up to your PayPal or whatever you pay with.
And you can be a member. I'm going to start doing some members only content, little videos and vignettes, since my skills are getting so good. It's just hard, but I want to do something like that for appreciation. When people, whoever wasn't here, people do beautiful things for me, like sending me this, but it's a compost. It doesn't look terrible, but it's it's for the garden. You wear it on your hip. I showed it in the beginning of the show. It's a composting tool from Jim and Tanya, who aren't here tonight, but people are so beautiful, and so I'm thanking you ahead of time, because I put a lot into it, and whatever. So,
well, thank you, Sandy, Jennifer, for putting all this energy into it. Your passion shows through, and your skills are just amazing. I'm just amazed.
Well, we don't have to do this every time. It's just that it's a labor of love. And I just say thank God that I can lay on my bed with a desk on me, because I am so, I could be very politically incorrect and say this. I'm not in good shape, but I'm here. And I will be with you guys as long as I possibly can, because me and Jennifer, man, we got a thing. we got a
thing going on.
Oh, hi, Hunter. All right. So anyway, it's been an hour and 3 minutes. I'm going to say goodnight. I want to thank everybody for coming. Jennifer, it's been a good show. I even learned more going through the articles again, and I read them twice today and watched videos. We do a lot of preparation for this stuff, and it's not just like we're just saying, okay, we're gonna throw this in. No, we talk to each other all week about what are we going to do on Sunday. So this is not some fucking excuse my language, just thrown together schlock job, as they would say in the Bronx. No, it isn't. So anyway, thank you guys. Pooh Ball says, I think you're an excellent scientist, Jennifer. Absolutely. She is.
Thanks, Pooh Ball.
And thanks, Nostradamus is with us. David, thank you. And Wendy
We
and
love
Osama, we
Nostradamus.
love you all. So thank you, guys. And we are going to say good night. Good night. Peace out. We'll see you together next Sunday.